All right, hello. Sorry, just let me set my timer for this video. Okay, there we go. I know I didn't stick to it last time, but I really wanted to finish that topic. Okay, so we are in Chapter 2, Section 5, Measures of the Center of Data. Now, we're going to do this problem that I've copied from your textbook here in just a second, but there's three measures typically for center. They are the mean, the median, and the mode. And you've probably seen these before, heard these before. Let's go over them real quick. Mean is your arithmetic average. You're going to take all your data, add it all up, divide by how many values you had, and that's your average, right? So, if you go the first value plus the second value plus the third value plus ... until you get to the very last value. So you have n values, you add those all up, and you divide by n. A shorthand notation for this, by the way, and you should get used to this notation, is the sigma notations. We have this fancy Greek letter sigma. It's just a capital letter sigma. Sigma S sum. We just use it for sum. Add them all up. So we have the x sub i's. The i's are indexed. So you add them all up and you divide by how many there are. That's all. And you just go from I equals 1 to n. So from x1 plus x2 plus x3, x to x sub n divided by n. It's your average. Median, we've talked about. That's the middle, right? You arrange your data from smallest to largest. You find the middle. Now, it might be in the data set if you have an odd amount of values. It might not be in the data set if you're even, and then you have to take the middle two values and average those together. Average, mean, right? And then you get your median. It's kind of funny that you have to use a mean to find a median, but whatever, right? Median is the middle, right? Mode, that is most common. So if you think about like what's the modal value, right? What's the mode? We're literally just asking like which number shows up the most, right? Which one do you see the most out of all of them, right? Yeah, there might be outliers. The average might be different, but like which one happens the most, right? That's all we're asking is like, hey, which one do you see the most often? That's all. So you have mean, median, and mode. Now, we have this example. Suppose that in a small town of 50 people, one person earns 5 million per year and the other 49 each earn 30,000 per year. Which is a better measure of the center, the mean or the median? We're going to actually calculate all three, the mean, the median, and the mode. Now, okay, what's the mode? What's the number you see most often? Yeah, it's 30 grand, right? There's 49 people that earn 30 grand. So the mode is 30 grand. So $30,000, 30K. What's the median? Okay, well, to find the median, we'd have to list it in order from smallest to largest and find the middle. So I've got 30,000, 30. I'm just going to write these in thousands, so assume these are in thousands. So 30, 30. Crap, I don't want to write that 49 times. So we have a whole bunch of 30s. And then we have our 5 million, which is 500,000. Or sorry, 5,000,000. That's what I meant. And huge, right? Where's the middle? Well, it's got to be, it's 20. It's the 25th value, but it's a 30, right? So the median is also 30,000. Now, what's the average? Okay, well, I don't want to calculate this by hand, but we can shortcut it just a little bit. Instead of adding up 30,000 49 times, we can just do 30,000 times 49 plus one copy of 5 million. And then divide by the total of 50 values. And there's absolutely no reason to do that by hand. Oop, I gotta erase my data from last time. Delete. Aha. Okay. So we have 49 times 30,000 plus 5 million. Oops, forgot to put an equal sign. And then we're going to divide that by how many salaries there were, which were 50. Yeah, 129,400. So The average is 129,400. Do you think that $129,000 a year really represents the center of our data? No, it's not. It's 4 times the salary of almost everybody in the town, right? It's not a good representation of the data. We have this incredibly extreme outlier with the 5 million, right? And this is like the office example that in a previous video where we're thinking about like an outlier can affect the mean, but it doesn't affect the median, right? So the median is 30K, and the mode, which we also see is most common, is 30K. What we're going to see is with outliers, with distributions, they're going to get pulled left or right by extreme values. And that doesn't mean that the average, the mean, is useless. It's often a helpful data, but usually it's helpful when the mean is close to the median, when we don't have these crazy extreme values. Okay, so that's a mean, median, and mode, which I'm pretty sure that you've seen before at some point in your life. Let's talk about 2 things left over from this section. First is the law of large numbers. Remember back to sampling videos or sampling topic, right? We have a population we're interested in. It might not be possible to talk to everybody in the population, so we take a sample, right? And now the population has some characteristic, some parameter that we're interested in. And so we estimate that parameter with our sample statistic, right? We take a sample, we do some calculations, and we get a statistic. The statistic is to help us find some information about the parameter. Now, what the law of large numbers says is, well, one of the things that the law of large numbers says is the bigger sample you take, the closer your sample mean, so that you take a sample and you take the average from the data in the sample, the closer that X bar sample mean will be to the true population mu. So we have some unknown population mean. So population parameter is our mean, mu. We don't know it, but we take a sample statistic. So our sample mean, so we have a sample mean X bar, and it's an estimate. And if your sample size n gets bigger, then X bar gets closer to mu. Better. Okay, now, the last thing, and this was one that trips up students a lot. It's a little tricky, right? Most of you have experience with calculating a mean. Even if you haven't seen this notation before, you've calculated a mean in your life at some point in school, right? But what if you have a frequency table? So I'm going to pull this example from, it's table 2.25 from your textbook. Take a look at it. Look, it has an interval of values, right? You see, it doesn't say a particular number. It just says it's somewhere between 50 and 56.5. There's one student in here. These are grades on a test, right? There was excuse me, nobody who scored in this range. From a 62.5 to a 68.5, 4 students scored in that range. I don't know what their scores are. I just know that they're in this range somewhere. And it keeps going. How are we supposed to calculate the sample mean? Now, of course, if we're the teacher, we actually have these exact values and we can do it. But given the data presented to us like this, where we only have a range, how are we going to estimate the mean? Well, what we're going to have to do is pick a value to represent each interval. So I want you to pause the video and think about this. What would be the most reasonable value to pick for each interval to represent the interval? You got it? Okay. Now, I actually think that there are several reasonable answers. You could say the lower endpoint. So in the first case here, that would be the 50 to represent the first interval. You might say the upper endpoint. So in this case, it would be 56.5 to represent the whole interval. Or why not take the average of the two? Let's find the middle of each one, right? So for each of these values, what we would do is find the middle. So if we do 50 plus 56.5 and divide by 2, so that is 106.5 divided by 2, which is what? 53.25, right? Yes, 53.25. Okay, so we will use 53.25 to represent this student. There's nobody in this value. It's going to be 0. It doesn't matter. And then we do the next one, right? So 62.5 plus 68.5 divided by 2. So I have 120, 130, 131. So I have 131 divided by 2. What's that? We have 65, 65.5. 65.5. So that's our middle. There's 4 of those, right? So what we do is we take the midpoint of each. So I'd have a 53.25 times 1 plus, I should have done this one right here. I'm going to cheat and look at the summed values real quick because I don't want to do all of those averages by hand. It's 59.5. So the next one would be 59.5 to represent the second interval, but no students scored on that one, so times 0. Plus the next one we calculated was 65.5. 4 students were in that interval, so times 4. Plus the next one is the next interval here. The midpoint from 68.5 to 74.45 is 71.5, and there were 4 students in that interval. And we keep going. What's the midpoint of this interval? The midpoint is 77.5. How many students were in that interval? 2 of them. Plus the next interval, the midpoint is 83.5. How many students were in that interval? 3 of them. So again, I don't know these 3 students. They didn't necessarily get the same score, but I don't know what their scores are. I only know that they're in a range. So I'm using the midpoint to estimate for each one, right? And we're going to keep going. Just a few more left. The next midpoint is 89.5, and there were 4 students that are going to be represented with that number, and the last one is 95.5. There was 1 student in that interval, and when you add them all up, you get 1,460.25. That's the total, and then what do you do with the total? Well, you divide by how many there are. Well, how many are there? Let's see. 1, 5, 9, 11, 14, 18, 19. So we do 1,460.25, the total, divided by how many there are, 19, and you get 76.86. So there is an estimate of the average. So when you're doing these, and you might be given the data as a table, you might be given it as a histogram, a bar graph, right? And you're like, okay, I have this written, like I know the frequency in this bucket, right? The frequency for this bucket was 1. Here's a bucket. How many were in that bucket? 4. Here's a bucket. How many were in that bucket? 2, right? So what do? You use something to represent that bucket, that range of values. Take the midpoint, multiply it by how many are in that bucket, and then do that for all of the buckets, add it all up, divide by how many values there are, and there is your average. And that is a tricky one. It trips up a lot of people. This is the way that you do it. Okay. And that is the end of Chapter 2, Section 5. As always, I encourage you to work through the examples in the textbook. They are good. They have some solutions there. And I'll see you in the next one.